Welcome in this lecture of shear force and bending moment diagram, where today we'll discuss the cantilever beam with the point load at the end. So today we'll discuss cantilever beam with point load at the end. So this is the today's topic. So we'll take this cantilever beam where one end is fixed and another end is free. This is called the cantilever beam, and the point load is acting here at the end of this cantilever beam, giving name P, and here the total length is L. This point I am giving name A and B. So this is the cantilever beam with the point load at the end. Now before solving this problem, we first know the shear force diagram. What is the meaning of that? The shear force diagram. So shear force diagram is nothing but it shows the variation of shear force, that I am writing this shear force as a SF, shear force along the length of beam. So this diagram, shear force diagram, shows the variation of shear force along the length of beam, means along the complete length or span of this beam, what are the shear forces acting, that this diagram shows. So this is called the shear force diagram, and shear force nothing but the variation, this shear force is nothing but the summation of all vertical forces acting up to the section. This is the meaning of shear force, means up to the sections we have to consider the vertical forces only, that is called the shear force. Similarly, I'm talking about the bending moment diagram. So bending moment diagram is nothing but it also shows, similarly it shows the variation of bending moment along the length of beam, So this is called the bending moment diagram, and bending moment is nothing but the summation of the moment of forces up to a section. So bending moment means only we have to take the summation of all the moment up to the section, and moment is nothing but force into perpendicular distance, that is a moment that we have to take. So this is all about the shear force diagram and bending moment diagram, and based on that we will solve this problem, the cantilever beam with the point load at the end of this beam. So to solve this problem we have to take some basic and important considerations, that is very important, which you have to do in the rough work. This you have to do in the rough work, but this is very important when you consider or this solving this problem of the cantilever beam with the point load at the end. Now first, the rule to solve this problem is you have to draw first the free body diagram. This is very important. So drawing the free body diagram of this problem is very important. Then second rule, you have to write the equation of equilibrium. This is very important. Then third point, the calculation of shear force diagram and bending moment diagram. And for this shear force diagram and bending moment diagram to draw, this is another important point that you have to put in your mind to draw this for the shear force diagram, and important point for shear force diagram and bending moment diagram. So this is very important with respect to or in consideration of the load. when we apply any load, how to draw the shear force diagram and bending moment diagram. This is very important point that we will discuss. If first the point load is there, if point load is there, for the point load shear force diagram will be this point load. If point load is there, shear force diagram will be vertical line, only vertical line. If no load is there, no load is there, then the shear force diagram will be horizontal line. Horizontal line, this is very important point. So if the point load is there, it will be the vertical line, the shear force diagram, only the vertical line we have to draw. If no load is there, horizontal line we have to draw. For the bending moment, to draw bending moment, if the point load is there, then the bending moment diagram will be inclined line only. This we have to consider in our mind. This is the important point to draw the shear force diagram and bending moment diagram, and this is the rule to solve the problem. First you have to draw this free body diagram, then you have to write the equation of equilibrium condition, then you have to calculate the shear force diagram and bending moment diagram. Now one by one we will solve. Now this is the problem. So this is the problem of cantilever beam having point load at the end, that is P, and this end is B, and this is the A. The total length is L. Now what we have to do, first we have to draw the free body diagram for that, and the free body diagram we know that for the cantilever beam this is point load P, and for cantilever this is suppose RA, suppose X, and the moment will be there MA. Because this is fixed in, so moment will be produced, horizontal reaction will produce and vertical reaction will produce, and this is the length L. The total span is here to here, this is the L, and I am starting from the free end, and the free end I am taking X is equal to 0, and this end will be X equal to L. Now the second is equation of equilibrium or support reaction we have to calculate. Now the next step, so first is summation of Fx equal to 0, all the horizontal forces we have to take, so we have only Rax, that Rax is equal to 0, no other horizontal force is there except this. Now next is summation of Fy equal to 0, all the vertical forces we have to consider, so vertical forces is P here and Ra here, two vertical forces are there, so only vertical forces we have to consider, but we have to consider the sign convention for that. If I am moving, suppose this is my right side and this is left side, this is the left and right, so if I start from the movement right to left, this side to this side, if I am going, so what we have to take, right to left, the downward force we are taking, downward force taking positive, downward force taking positive, so downward force will be positive when we are moving right to left, and upward force will be negative, that we have to take negative when we move right to left. Now here we can see that when I am going right to left this side, so P is a downward, so I am taking P as a positive force, and Ra I am taking, this is Ra or Ray you can say, no problem, so Ra is a negative equal to 0, so Ra here is P. This I am giving equation 1, no problem. Equation 2, Similarly, I have to take moment about A, because these are the coplanar forces, and here the coplanar forces means the moment they will produce moment, as already we have discussed in the previous lecture of the shear force and bending moment diagram. So in the coplanar forces they will produce the moment. So moment about A, so about A, this is the A. If I take the moment about A, this is the A. So moment about A, if you take P into L, the force into perpendicular distance is equal to L. So this is the moment about A. So equation 3. Now this is the equation of equilibrium. Okay, now third point, if I see here, is the calculation of the shear force diagram. So calculation of shear force diagram. So first we have drawn the free body diagram. Second, we have written the equation of equilibrium. Then we should calculate the shear force diagram. For the calculation of the shear force diagram, some steps are there, steps that we have to follow. So if this is P is there, and this is the RA or AX and MA. Now as per our definition for the shear force is nothing but it is the summation of all the vertical forces up to a section. So here, to calculate the shear force diagram, we have to consider a section, and I am considering anywhere else in this span you can consider the section. So I am considering this is the section XX, this is the x equal to 0, and this is the x equal to L, and from here to here I am just considering this is the length x. Suppose x length is there. So if I draw these things, this is the beam where P is acting here, and the shear force I am giving, the shear force, the symbol for the shear force is V. This is the symbol for the shear force. Okay, so symbol for the shear force I am giving here as a V up to the section X. So the downward force will be positive and upward force will be like this. So V is equal to P up to a section A, V up to a section A, this will be there, means up to here the shear force will be P. And similarly, if I calculate from here to here, same way I have to calculate. So now the steps for this, to draw the shear force diagram, the step 1, because here to here, because there is a no load is there except this P at the end, so shear force will be equal to P. Similarly, if I move from here up to RA, the shear force will be P only, because from this point to this B point to A point there is a no another vertical forces, so this force will be constant up to this A point. So that's why the shear force will be equal to P. Now how to draw the shear force diagram? To draw the shear force diagram, first step is that this is the point B and this is the point A. So we have to take the first 8B or before, just before the B, you can see this is the point 0 point here, just before B, so 0, and at B the P is there. So at B, if you see at B, the shear force is P only at B. Now similarly, just before A, what will be the, just before A, the shear force, just before A, the shear force will be P only, and at B 8b, 8a, this is a, 8a. So p will be there, p which is positive, and at a, ra value will be nothing but p here, ra, and ra is nothing but p, because we know that ra value is equal to p. Already we know the previous calculation, so 0. So at a the value will be 0. We can calculate in this way. So from this way we can draw the shear force diagram. So to draw the shear force diagram, we take this type of graph where this x-axis shows the span of the beam or this complete beam, and this y shows the shear force. This is positive shear force, this is negative shear force. Now at point B, this is the point B, at point B this shear force, at point B shear force is a P, and P is a positive because it's a downward force, so we are considering P is a positive. Some value will be there of P, here it is P. And just before the A, this is the point A, suppose this is the point A, and just before A this will be the constant, because we know that as the shear force is P up to the section X, similarly if you move X to A, this shear force will be P only because no other load is there. Okay, so how to draw this shear force diagram? We know that already in this important notes that if the point load is there, the vertical line will be there for the shear force diagram. So at point B, because it's a point load P, so the vertical line will be there, but it is in the positive way because P is a downward force which we are taking as a positive, so it will go positive side. And there is a no load in this span, there is a no load, so it will be the constant as we have discussed here, no load, horizontal line will be there. So just before A, this is just before A, it will be the horizontal line similar to the P. Whatever the load of P will be there, the P value, it will go horizontally here up to just before A, and we know that at A it is 0, so we are coming here 0. So this is the 8A. Now again we are coming in the 0, and this diagram will be positive because it is the positive side. So like this we can draw this shear force diagram. Means this is the steps. 8B, what is the load? Vertical load. Shear force means only vertical load we have to consider. So vertical load is a P, 8B, and P is a downward force, that's why it will go in the positive side, and it is a point load, that's why it is a vertical line, and there is a no load, so horizontal line will be there, and it is constant up to just before A, because just before A, RA value is nothing but P, RA is equal to P, so up to RA it will be P value, and at A P minus RA equal to 0, so it will be come back again at point A 0, and this is the box like diagram which is positive because it is in positive side. So this is the shear force diagram. Now we'll see the bending moment diagram. Bending moment diagram for that. As we have discussed that bending moment is nothing but it shows the variation of bending moment along the entire length of the beam, and the bending moment is nothing but it is the summation of the moment of forces up to a section. So again here we have to consider up to a section. So suppose this is the beam and the point load is there, so we can consider up to a section here, x, this x equal to 0, x equal to L, because I am moving from this side, right side to left side, and entire length is L. So up to section X I am considering, I am cutting this section. If I cut this section, looks like this. This is the XX point. This is the nothing but X distance, where X equal to 0, and here X equal to X. Okay, so step to draw or to calculate the bending moment diagram calculation. The calculation for the bending moment diagram steps, we have to same consider. First we take the bending moment at section X. Bending moment at section X. Okay, so this is the section because the load P is applying on the beam and it tries to rotate the beam downward side like this. So it tries to rotate the beam this side. So as per our sign convention for this bending moment, it looks like this. When the P pushes this beam downward side, so it will be negative as per our sign convention, and it is called the hogging like this. So if I move right to left, this type of movement we will take negative. So here the bending moment is nothing but the P into perpendicular distance. So bending moment at X, we are taking P into X, and the rotation is this manner, hogging, so we will consider as a negative. Now here we can see the bending moment diagram. Since mx equal to minus px, now at x equal to 0, then m0 equal to nothing but p into 0, that is 0. So at x 0, this was our cantilever beam, this is the p, and x equal to 0, x equal to L here, and here our section is there x, and this is nothing but the x distance. So x is 0 means at the point of B, this is A, the point of B the moment will be 0. Similarly at x equal to L, if I put x equal to L up to this distance, up to this entire length of beam, so ML is nothing but minus P into L. So this is nothing but PL, means at this point A the bending moment will be minus PL. So this was the calculation. Now how to draw? Similarly, you draw the bending moment positive side, negative side. So here you can see that this is the point B. So step for the calculation of bending moment diagram 8B. 8B, the bending moment 8B, bending moment equal to 0. So 8B bending moment equal to 0. See here 0. Now just before A, this will be minus PL, and at A this will be minus PL plus PL equal to 0. Already we have calculated, it was a plus PL at this M. Bending moment at A already we have calculated, bending moment at A equal to PL. So means at A it will be 0 again. So at A it will be 0, at B it will be 0, and just before A it will be some value that would be minus P into L, because it is negative side, so we are taking this as a negative. So, and we already discussed that the bending moment, if you draw the bending moment and point load is there, it will be inclined line. This is very important. So now we can draw this inclined line. This is one point where the bending moment is 0, and this is the just before the A, its PL value, and at A it's 0, again it goes at 0. So this is the negative. So this is the bending moment diagram. bending moment diagram for the point load acting at the end of this cantilever beam. So this is all about the shear force and bending moment diagram, how to draw the shear force diagram and bending moment diagram. It is very important, and these steps you have to follow. If you follow this step, then you will clearly solve the problem of this cantilever beam with the point load, any point load in any section of this cantilever beam. Thank you.